Hello, this is Mr. Stansbury. I'm going to take you through the 15 G notes on valid arguments. Okay. At the end of this, you should be able to say, I can determine the validity of two logical arguments by using a truth table. All right. So let's first talk about an argument. An argument is made up of premises or propositions that lead to a conclusion. Okay. And often these arguments will include therefore or hence or something like that. Okay. An argument is valid only if it's a tautology, so everything needs to be true in the final column. Okay. All right. So, excuse me. With that, let's look at example 11 from page 510. What conclusion results from emus cannot fly and Jane is an emu? All right. So we're going to look at this in our logical way here. So first off, we have our two premises or propositions. First premise we will say is emus cannot fly, and then the second premise is Jane is an emu. Okay, so now what we need to do is we need to draw a conclusion. Okay, so hopefully from that we can say, okay, since Jane is an emu and emus cannot fly, we got to say that Jane cannot fly. So that would be our conclusion. Okay, and we would call that R. All right, now we can also represent this here. Instead of writing it all out like that, we can represent it with our letters here, like so. So P, Q over Q, and then with a line, and then R. So that is the premise, this premise which leads to this premise. Well, this premise and this premise together leads to our conclusion, which is R. So that's what the line shows. So P and Q gives us R. All right. Okay. So let's take a little short video break because I love these videos. So I'm gonna show these to you.
I read all these kids' books, you know. Let me ask you something. Does the owl go who, or does it go hoot? Half the books say one, half the books say the other. Let me tell you something. Owls don't go hoot, okay? Has anyone ever heard an owl go hoot? Hoot! Never in the history of the animal kingdom has an owl enunciated like that, ever. Toss those books in the trash can. They didn't do their research.
All right. So with that, let's take a look at one more example, and that is example 12 from page 511. All right, so we have a couple of, let's see, what did we call those again? We are now calling them premises. Okay, so first premise is the sky is purple, and then the second premise is my cat is fluffy. Okay, is this a valid argument? P implies Q and Q, which should lead us to the conclusion of P. All right, so we are going to take a look at that. So what we want to do here is we want to make ourselves a little truth table here with P's and Q's. So again, with what we want to do is always start with the last one and go true, false, and then the next one over, true, true, false, false. Okay, so the first thing we want to do is we want to figure out P implies Q. So that's going to be this one here, P implies Q. All right, so if you'll remember, for our implications, you want to remember the ingredients and making the world's best cookies, right? So if you have the ingredients and you make the world's best cookie, so that's true that you have the ingredients, true that you make the world's best cookie, you can assume that that is a true statement. Okay. If you have the ingredients but you cannot make the world's best cookies, then you have to assume that that would be false then. And remember, if you don't have the ingredients, you can't disprove or prove it either way. So you have to just assume that it is true. So both of those would be true. So here's our P implies Q. All right. So now what we have is we have P implies Q. Now we want and Q. So this line and this line. So when you have these two implications, no, not implications, but I keep forgetting premises. When you have these two premises, this premise and this premise here, you always want to connect them with and. So then what we're going to want to do, is, let's see, we are here. Excuse me, we want to do P implies Q and Q. All right, so we want to do P implies Q and Q. So here's our P implies Q, here's our Q. If it's and, they both have to be true. So true, true, this would be true. False, false, that is definitely not true. True, true, that would be true. And then false, true, since they're not both true, that would be false. Okay? So then our last piece would be P implies Q and Q, so this one here. And then does that lead us to P? So does that imply P? So then we would write P implies Q and Q. All right, and I'm going to put that maybe all in parentheses so we know that that's the original part. Does that imply P? Okay, so this here, does this lead to this? So we're going to ignore really these two pieces here, these two columns. We're just going to look at this column and this column. And again, we're starting with this column here. Does that imply this? So again, true to true, that would be true. False, again, if it starts with false on an implication, you have to assume that it's true. Starting with true, ending with false. So you have the ingredients, but you don't make the best cookies, so that would be false. And then again, starting with false, you don't even care what this other one is because you can't disprove it, so you have to go with true. So is this here a valid argument? The only way this would be a valid argument is if this is a tautology. Since we have this here being false, this is not a tautology. Not a tautology. So it is not a valid argument. Okay? All right. So you should now be able to say that I can determine the validity of two logical arguments by using a truth table. Excuse me, truth table. If you have any questions, please ask. Thanks.